If you just stop and think about your life for a minute, you use software for, well, for almost everything.
For everything.
From the simplest thing, like a payment transaction,
Yeah.
to navigating these huge, complex enterprise systems.
Right, like managing a global supply chain or even running a university's payroll.
And everyone uses the output, but I think the vast majority of people, they never really see the engine. They don't understand the roadmap.
It's so true. The whole process from that initial, that spark of an idea to it becoming this scalable global system running in the cloud, it feels like a complete black box to most people.
A total black box.
Yeah, they see the interface, the app on their phone, the new AI feature, but they miss the foundational architecture and all those critical decisions that were made long before anyone wrote a single line of code.
And that's exactly where we come in today. Our mission is to cut through some of the complexity. So whether you're a professional who needs to talk about digital transformation, or maybe a student mapping out a career, or you're just curious about how this all works, we're going to give you a shortcut. We're going to walk through the entire life cycle to show you how systems think.
And here's the first big realization, probably the most important one. Software doesn't start with coding.
No.
It starts with a problem that needs a solution.
Okay, let's unpack that, because that assumption that building software is just a coding marathon, that's what traps so many people in, outdated thinking. So if it doesn't start with code, where does it begin? And why is that initial phase so critical?
It begins with meticulous business process analysis. We're not building tech for the sake of tech. We're addressing a very specific need.
Right.
And usually we can distill those needs down into 3 key categories.
Okay, give us a breakdown.
First, you've got user pain. This is just the sheer frustration of using a bad design, a confusing interface, a sign-up flow that's impossible.
The form that keeps giving you errors.
Exactly, the classic headache. Then second, and this is a big one for efficiency, you have process inefficiency. Think about all the systems that require manual data entry, or those long winding queues for student services.
I instantly think of old finance systems where someone has to download a report, filter it in Excel, and then upload it somewhere else just for one number.
That's the perfect example. And the third category is system limitation. This is often an internal problem where your existing platforms they can't communicate.
Oh, the classic data silos.
Exactly, the data silos. Your inventory system can't talk to your finance system, and they certainly can't talk to your customer relationship platform.
So, okay, before we can even dream of a solution, we have to look at the mess we're already in. Which brings us to business process analysis.
Absolutely fundamental. You cannot automate chaos. A business process is just a structured series of tasks to get something done, like hiring someone or fulfilling an order. If you skip mapping out the current as-is process, you risk just writing code that digitizes all the existing problems.
That is such an excellent point. You're not actually improving the business, you're just making the bad process go a little bit faster.
Precisely. And that's why tools like ERP systems, enterprise resource planning, are so important. They exist to integrate and standardize those key processes.
Like enrollment, payroll, finance.
All of them, across the whole organization. Using an ERP for finance, for example, forces you to use standardized inputs and outputs, which makes everything downstream much, much cleaner.
Okay, so we found the pain point, we've mapped the messy process. Now we have to go from a vague idea, like we need better enrollment, to a concrete plan, the requirements stage. How do we make sure these requirements don't completely derail the project later on?
By translating that idea into measurable, unambiguous statements. And we separate them into 2 crucial buckets. First, you have functional requirements. These say what the system must do.
Simple actions.
Simple actions. The system must calculate federal tax withholding, or the system must allow a user to reset their password. Very direct. The second bucket, and this one is often underestimated, is non-functional requirements. This is all about how the system must be, its quality.
So things like speed, security.
Exactly. Must load in under 2 seconds, or must maintain 99.999% availability, or must be fully GDPR compliant.
Okay, wait. If requirements are that important, what's the single biggest mistake people make with the non-functional ones?
Assuming the technology can just handle it. For example, a functional requirement is upload a 50 GB video file. Simple enough. But the non-functional requirement says the upload must finish in under 3 minutes, no matter where the user is. That changes everything. That speed requirement fundamentally alters the entire architecture. You need different servers, content delivery networks. You might have to rethink the whole process.
So failing a non-functional requirement can kill a project even faster than a functional one. A button that calculates taxes a little wrong is bad, but a system that crashes every day or is unusable.
It's catastrophic.
Yeah.
Precisely. Bad requirements, especially vague or impossible non-functional ones, absolutely lead to bad systems. No amount of brilliant code can save you from that.
Right. So we've got the blueprint, the requirements are set. Now we need the people to build it. It's not just one developer in a dark room, is it?
Not at all. It's a whole integrated team. You have the business team defining the needs, the analyst translating those needs, the designers creating the user experience.
And then the developers, testers, and stakeholders.
Right. And once that team agrees on what needs to be built, they have to decide on the architecture, the structure.
What are those fundamental digital divisions for pretty much any modern application?
You need a foundation that separates concerns. So every platform, from a simple website to a huge enterprise system, it generally has three basic parts. The front end, which is what you see, the interface, the buttons, the colors.
What the user interacts with.
Yes. Then the back end. That's the logic, the operations, the security,
Yeah.
all running behind the scenes.
The brains of the operation.
Exactly. And the third critical component is the databases. This is where all the data actually lives. User profiles, financial records, inventory counts, everything.
Let's drill down on that data storage for a second because that choice seems to define so much. We always hear about SQL and NoSQL. Why does that choice matter so much?
It's fascinating because you're essentially choosing a philosophy for how to handle information.
A philosophy.
Yeah, SQL or structured query language. Well, it's structured and relational. It's built on these tables with defined relationships, which ensures really high integrity and consistency.
And like a highly organized library catalog.
That's a perfect analogy.
Yeah.
Everything is indexed, organized, cross-referenced. You need this for things like financial ledgers or banking systems, where every transaction has to be perfect.
Okay, so what about NoSQL?
NoSQL is more of a family of databases that are much more flexible. They're great for unstructured data, and they scale out horizontally really, really fast. Think of huge streams of data, like user comments on social media, or data structures that change all the time.
So if I'm building, say, an inventory tool where every product count must be exact, I'd probably choose SQL.
Most likely, yes.
But if I'm building a giant social media feed with billions of posts updating constantly, I might lean toward NoSQL for that speed and flexibility.
That's the trade-off. You get phenomenal speed, and you can handle massive distributed data. But you sacrifice some of that immediate relational consistency that SQL guarantees. Success here is all about choosing the right tool for the job, not just what's trendy.
Okay, so we built the system, we've chosen our architecture. Now we need a place for it to run and, more importantly, to scale. Let's talk about the cloud. For a lot of people, it's still just a vague marketing term.
Yeah, if we connected to this whole picture, the cloud is just the delivery mechanism for modern computing. It's not some mystical fog. It's a huge network of physical data centers, servers, storage, all run by major providers.
And when we talk about that infrastructure, we're talking about servers, databases, and this other critical piece called APIs, right?
Absolutely. The API, the application programming interface, is maybe the most important concept in modern architecture. It's the mandatory translator. It allows different pieces of software to talk to each other securely and reliably.
So without APIs, the front end can't talk to the back end.
And the back end can't get data from the cloud database. APIs are the secure gateways for all communication between all the components.
Which is where that big strategic shift happened, right? Companies moved away from running everything locally. On-premise, they call it.
Yes, on-premise, using their own servers in their own building to using these big centralized cloud systems.
And why was that shift so mandatory for any company that wants to grow?
It comes down to the necessity of scale and availability. If you're a global company with customers in Europe, Asia, and North America, you can't rely on one data center in Chicago. It'd be too slow for everyone else. Exactly. You use cloud regions, these geographically spread out data centers, to make sure everyone has low latency, meaning the system is fast for them.
And beyond speed, there's availability.
Yes. The infrastructure has to handle 10 users or 10 million users without breaking. That's scalability. And all those non-functional requirements we talked about, security, backups, reliability, they're so much easier to manage with professional cloud services. They have economies of scale and security teams no single company could ever replicate.
Okay, so the cloud guarantees those pillars. Speed, scalability, security. Now let's bring in the component on everyone's mind, artificial intelligence. Where does AI fit on this map?
We have to frame AI correctly. It's fundamentally a highly sophisticated component inside the system. It's not some magic thing operating on its own.
Right. It doesn't just float in the ether. It needs powerful computers, which means it lives on that same cloud infrastructure.
Absolutely. The AI model itself is built, trained, and run on cloud services. Then it connects to the main application and the databases through those APIs we mentioned. The database feeds the AI information, customer data, inventory levels, and the AI performs a service.
Like giving product recommendations or running a smart chatbot.
Exactly. So AI doesn't replace the architecture. It just enhances a specific part of the system's logic, and it needs the same robust foundation as everything else.
That's a key takeaway. It's a powerful new module, but in a very familiar framework.
hmm And this view brings us to one of the most important truths about this whole life cycle. A system is never really finished.
Right. You don't just launch the new enrollment system and walk away. That launch it and forget it idea is a total relic.
Correct. The modern reality is continuous improvement. It's agile thinking. The philosophy is all about rapid development cycles, constant feedback loops, and adapting to change. You launch a minimum viable product.
Just the basic.
Just the basics. You gather data on user pain points, find inefficiencies, and then you quickly update and improve. That cycle of building, measuring, and learning never, ever stops.
Which means the entire system is always evolving. And that implies a huge shift in the skills people need, doesn't it?
It really does. The sources are very clear that focusing on memorizing specific programming languages or tools,
Yeah.
it's a dead-end street. The tools change every 18 months.
So what are those skills that endure?
Well, first and foremost, problem solving. That's the skill that starts this whole process. If you can't define the problem correctly, the solution is worthless. Second is process thinking, the ability to map and analyze a messy business process. Third is high-level communication, turning vague ideas into those concrete requirements.
And wrapping all of that together is what the sources call a systems mindset.
Yes. Understanding how all the components interact, how the front end talks to the back end via an API, how data retrieval affects speed, how security works, that's so much more valuable than being an expert in just one piece of code.
So the educational priority has to shift.
It must. From how to use a tool to understanding how systems think, and most importantly, learning how to learn.
Yeah.
Because adaptability is the ultimate non-functional requirement for any modern professional.
Okay, let's bring it all the way back around. We started this deep dive with just an idea, a user's pain point. We mapped the process, we defined clear requirements, both functional and non-functional, and we chose the right architecture to fit the job.
Front end, back end, a database.
Then we deployed that system to a highly available cloud infrastructure to make sure it can scale and be secure globally, maybe even integrating components like AI.
It's a full journey, really, from a conceptual business challenge all the way to the highly technical demands of global infrastructure. And understanding that whole continuous loop is essential for anyone today.
So what does this all mean for you? We just walked through the entire life cycle of a modern system, a system built on this idea of continuous improvement and iteration agile thinking. So if the most valuable, robust systems in the world are built on the philosophy that nothing is ever truly finished, that every launch is just the beginning of a new iteration, my closing thought for you to mull over is this. How should we apply that same philosophy of continuous iteration to our own professional development and our own personal learning? Are you iterating on your knowledge as often as a developer iterates on their code? Think about that until the next deep dive.